Hello and welcome to podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who supports the show on Patreon. Your contributions help to make the show sustainable. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at podcastinit.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your app. And now you can deliver your work to your users even faster with the newly upgraded 200 gigabit network in all of their data centers. If you're tired of cobbling together your deployment pipeline, then it's time to try out GoCD, the open source continuous delivery platform built by the people at ThoughtWorks who wrote the book about it. With GoCD, you get complete visibility into the life cycle of your software from one location. To download it now, go to podcastinit.com/GoCD. Professional support and enterprise plugins are available for added peace of mind. You can visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. And if you have any questions, comments, or suggestions, I would love to hear them. You can reach me on Twitter at podcastinit or email me at hosts@podcastinit.com. To help other people find the show, please leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. We've got a few announcements before we start the show. First, there's still time to register for the O'Reilly Software Architecture Conference happening in New York, February 25th to the 28th. Use the link podcastinit.com/sacon-new-york to register and save 20%. If you work with data or want to learn more about how the projects you've heard about on the show get used in the real world, then join me at the Open Data Science Conference happening in Boston from May 1st through the 4th. It has become one of the largest events for data scientists, data engineers, and data-driven businesses to get together and learn how to be more effective. To save 60% off your tickets, go to podcastinit.com/ODSC-East-2018 and register. I'd like to thank O'Reilly Media for offering 2 items to give away. To enter, you just need to subscribe to the mailing list at podcastinit.com, and you'll have the chance to win either a copy of Neal's book, Building Evolutionary Architectures, or a bronze pass to the O'Reilly Software Architecture Conference happening in New York. I'll be picking the winners on February 21st. Your host as usual is Tobias Macy, and today I'm interviewing Neal Ford about the principles of software architecture for developers. So Neal, could you start by introducing yourself?
Absolutely. Thanks for having me. My name is Neal Ford. I work at a international consulting company called ThoughtWorks. I've been there for almost 13 years now, and most of my professional work is in the intersection of software architecture and things like agile engineering practices.
And do you remember how you first came across Python?
I first saw Python many years ago because it was a sort of a variation on Lisp, and I have a deep love for Lisp and variations of Lisp, and Python is in that family of languages. So I've always had a fondness for it, and we keep bumping into it professionally. One of the things that ThoughtWorks does is twice a year we release this white paper. Basically, I mean, one of the superpowers of being a consultant in a large consulting company like this is we get to pattern match things across a large swath of projects. And we do this twice a year with this thing called the ThoughtWorks Technology Radar. And on our last radar, we actually called out the fact that Python keeps growing in our clients' usage, and it keeps popping up in all sorts of interesting places. And we're seeing more and more of it showing up in the enterprise world.
And as you mentioned, a major focus of your work has been on software architectures and how those can be used to facilitate the delivery of working software systems. So I'm wondering if you can start by just giving a high-level overview of what software architecture is in your experience and how that fits into the overall development process.
Boy, I would love to be able to give a nice, concise, high-level overview of what software architecture is, but I don't have a clue of how to do that. In fact, better minds than me have cast themselves against that particular mountain and failed. Martin Fowler famously wrote a white paper called Who Needs an Architect, where he talks about the lack of definition of software architecture and why that exists. And one of the sort of side roles I have is the co-chair of the O'Reilly Software Architecture Conference. It happens in New York in February and in London in October. And one of the things when I moved into that role that they asked me, sort of as a subject matter expert at O'Reilly about all things software architecture, is, can you give us a really nice, succinct definition of software architecture? And I said, no, I can't. And they kept pushing me on this. And I tried to explain to them that it's a very nuanced, very broad very multifaceted discipline and really hard to define. And they kept asking me, so I finally produced a fairly complex mind map that tried to touch on all the different aspects of software architecture. And even that was woefully incomplete. But I think they started gathering up the scope of what you talk about when you talk about software architecture, because it really encompasses the things that most people think about when you talk about software architecture, which are the kind of structural scaffolding of how software projects fit together. But it also encompasses a lot of things like soft skills, like, being able to conduct a meeting and lead a team and be able to convince people. It doesn't matter how brilliant your architectural vision is. If you can't convince business people to spend money on that vision, you're never going to get to implement it. So part of that is part of software architecture as well. So it's hard to pin it down because it's so nuanced, and it keeps growing over time. For example, many years ago, maybe 15 years ago, architecture and operations were completely separate things and were often housed in different buildings and sometimes run by completely different organizations. In other words, it was common to outsource operations. But you look at modern architectural styles like microservices, and part of the superpower of microservices is this ability to treat operations as an architectural aspect of your system. And so that's an example of how the influence and the scope of architecture has grown even within the last 5 or 6 years.
And when I was looking through some of the beginnings of your recent book about evolutionary system design, one of the things that it covers in the first chapter is the concept of software architecture. And as you said, there are so many different components to it beyond what you just think of with the software pieces of it, including the data and the processes that go around it.
So one of the things that people have traditionally said about software architecture is it's the stuff that's hard to change. That was one of the kind of colloquial tongue-in-cheek definitions of software architecture, is it's the stuff that's hard to change later. But then things like microservices came along and they actually built change into the architecture. And we realized, hey, if you actually build it to facilitate that, then it's not nearly so difficult. One of the problems I think that we're trying to address in our book is that for a long time, software architects have been treating software architecture almost like a mathematical equation. It's something to be solved, and once you've solved it, you can kind of drop the whiteboard marker and walk away. But it's a living, breathing thing, and it's constantly changing, and it changes in two ways. Now, we normally think of change just as a singular thing, but it's really two things. One way it changes is driven by the business because, the business changes, or you merge with another company, or you start in a new line of business. But the other kind of change is kind of insidious, and it's the one that really nabs us, and that's the ecosystem change. So I've been talking to a lot of enterprise architects over the last couple of years in the process of writing this book, and I'm preparing to write another book more focused on enterprise architecture. And I've been asking them this question, sort of tongue-in-cheek, but to really drive home the point. I've been asking them the question, can you predict with any certainty what JavaScript web framework you'll be using 2 years from now? And of course they can't, because it probably hasn't been written yet. But that's a big problem for the traditional role of software architects, which is all about long-term strategic planning. You can't do long-term strategic planning in an ecosystem that is as dynamic as ours. And so one of the things we're trying to do in this book is to get people to think about architectures as living things that change all the time. And in fact, change may be thrust upon you by the ecosystem that you're in. You didn't plan to change your JavaScript front end, but you had to, because the one you're using, suddenly the dude who wrote it decided he wanted to become a surfer instead, and now no one's maintaining it, and you got to move to something else. So I think the world that we live in increasingly forces us to treat architecture as very much a dynamic thing and not a static thing anymore.
And the counterpoint to that, too, is the system that anyone who's been in the industry long enough has come across, where it started off with the best of intentions, but over time it has accrued enough technical debt that forward progress becomes nearly impossible because of the level of fear that's involved with changing any aspect of the system, because you don't know what's going to break and why. So I'm wondering if you have any sort of general principles that you've come up with that are useful for being able to guard against that eventuality, or to get somebody unstuck when they do end up in that situation.
Yeah, we've got a bunch of them. In fact, we wrote a whole book about them. But that's a really common problem that you run into. And part of that is this idea that architecture can't change. And part of that is really around something you alluded to earlier, is the engineering practices that really lead you to be able to do really good architectural stuff. So there's a great case study that we talk about in our book from the GitHub engineering guys. They have an engineering blog, and there's a blog entry called Move Fast and Fix Things on the GitHub engineering blog. So one of the things that people are terrified of are the architects are terrified of making substantive structural changes to existing systems, because they're afraid of introducing regression bugs and breaking things that were working before, and suddenly things are more, unstable where they used to be really stable. And that's exactly what this blog talks about. Now, GitHub is a very, very aggressive organization from engineering practice standpoint. They deploy on average 60 times a day. So they practice continuous deployment, and they're very aggressive about that. And this blog talks about them creating this tool called Scientist, and they actually open sourced it, which allows you to experimentally replace bits of your infrastructure without breaking stuff. And so basically what it does is allow you to set up experiments so that for 1% of the cases, it runs the experiment in addition to what it would normally run, and allows you to compare times and outcomes and make sure that the thing you're replacing is working exactly the same way as the old one before you actually make that structural change. And so that's a good example of, so one of the things that people used to think was, well, you want to build architecture to be as stable as possible so you never have to change them. But that's a fool's errand now, because everything changes all the time and you can't make it stop. The only way to really make that possible is to embrace the idea that everything's going to change all the time and get really good at being able to incorporate change. And so that's all the stuff that we learned over the last not quite decade about continuous delivery and continuous deployment and all the engineering practices that come along with that. So that definitely helps build an architecture that can withstand change, is having the actual moving parts to enable you to withstand change. But there are other ways that you can do this as well. We have an entire chapter about migrating architectures from one kind to another, because you very often build an architecture for one purpose and then your business changes, or the nature of why you're building that system changes. And very often, so there are a bunch of common architectural patterns out in the world, like, layered monoliths or microservices or microkernel or event-driven architectures. And each of those encapsulates some desirable set of architectural characteristics, but no architecture supports all of them maximally. One of the words that you hear most often associated with software architecture is the word trade-off, because there are no good, clean binary choices in software architecture. Everything is some sort of messy trade-off. And the art and craft and skill of software architecture is given the constraints that you have driven by the business requirements, plus all the external constraints driven by the ecosystem you're building the code in, and expected number of users, and what sort of change you're anticipating, is finding the right sort of architectural pattern that tries to maximize as many of the desirable characteristics you want and minimize the ones that you don't want. And so you choose a particular pattern, but then your business goals change. Maybe you started out by being, a slow-moving commodity kind of business, and you're trying to convert yourself into a fast-moving kind of modern economy kind of business. It's hard to change the fundamental characteristics of your architecture. You can do that, but it's a very difficult thing to do, and you have to do it very slowly and piecemeal. One of the best pieces of advice that I can give from an architectural standpoint is improve the modularity of what's already there. So most good architectures have some degree of separation and modularity, and generally the firmer the degree of separation, the better off you are, as long as you haven't gone crazy and created artificial degrees of separation. And so a really common goal that a lot of people are pursuing right now is taking monolithic applications and restructuring them into service-based or microservice architectures. And we do a lot of that work actually professionally right now. And the first step in that process is improve the modularity of what's already there. figure out what is actually coupled to everything else, and which of those things do we really need to share and preserve that coupling point in the new architecture, or do we need to duplicate that functionality and break the coupling point? And of course, there are pros and cons of trade-offs of each of those things. But that analysis helps you figure out exactly where the seams are between the modules in your existing architecture, and that in turn helps you figure out how you can successfully restructure it.
And for people who are working in smaller companies, when they think about a software architect, it's generally associated with larger companies or enterprise, and as being a dedicated role of somebody who says, this is how the system is going to work together, so go ahead and build it. So I'm wondering if you can talk a bit about where the responsibility of software architecture lies, and at what point does it make sense to break it out into a dedicated role within an organization versus making it just be something that each of the developers needs to consider in the process of building a working system?
It's a great question. In fact, one of the things that we've identified for the O'Reilly Software Architecture Conference is this role that we describe as the accidental architect. Because if you make a decision on a software project, even if you're a one-person project, if you make a decision that has a major structural impact about architectural characteristics, then that is an architectural decision. Whether you have that title, or you have the accolades and the headaches of that, the officialness of that role or not, that is the role of architect. So it is not something that has a hard, distinct boundary. It's a very, very fuzzy spectrum. Because any decision that really impacts these things that we call architectural characteristics. So there's a great list on Wikipedia called a list of system quality attributes, which are all the things that you could support in architecture. Really being able to support all those things is impossible in an architecture. And so that's really what you're trying to do in architecture, is maximize or pick which one of those you think is the best ones that you want for an architecture. And if you're making that decision as a developer, you're making an architecture decision, whether you call yourself an architect or not.
Digging a bit deeper into that, I'm wondering if you can sort of characterize the responsibilities of somebody who does have that architect role as their job title versus somebody who is operating at the individual contributor level.
Like I said, it's a really fuzzy spectrum. So we have some projects that have that distinct role, and very often what that role means is that's the decision maker or the person who is accepting responsibility for this whole slew of things that need decisions about. So, for example, this is something that came up on a project not too long ago. So we had an existing architecture, and we needed to make a change because we were changing the nature of the business. So we had a single connection to the outside world, and we were adding two new kinds of connections to the outside world. And the question came up from an architectural standpoint, do we want to use a dedicated message queue for those new connections, or do we want to share the one we already have? That's an architectural level decision, whether you're an architect or not. And being able to make that decision requires some analysis. You have to go and be able to ask some questions. What's the expected throughput of this? Do we need to know from the destinations from where the message is coming? Because that might have an impact on that architectural decision. And so that thought process that you go through is really the role of architecture. Whether you're formally doing that or informally doing that, you should capture that somehow, because that's really what you're doing as an architect, is working through this list of, here are the things I need to consider, here are the outcomes of those things, and the assumptions that I'm making as I build this particular architecture, because, someone going forward may need to know that assumption, because, fundamental assumptions may change over time, and so that may change why you're using one particular architecture.
And bringing it to the language level, I'm wondering if there are any aspects of different programming languages and their associated ecosystems that play a major role in influencing the style of architecture that is generally used within that community, or the architectural patterns that you're actually able to implement.
Yep, absolutely. It has a huge impact, because in many ways, the language is the building blocks for the kinds of things that you could build easily within an architecture. You can put an enormous amount of effort and, build almost anything using any kind of software, sometimes with enormous, ridiculous effort to do that. But there are sweet spots that each language and each platform offers. A great example of your question is when the functional programming stuff finally made it to Java in Java 8, because there's a common architectural pattern, this kind of pipes and filters architectural pattern that was not commonly used in Java because it was a little bit cumbersome to put together, and it was much more commonly used in ecosystems that more commonly had that language pattern, like functional programming languages. This is where MapReduce kind of ecosystems and frameworks and tools like Hadoop come in. So that's a very natural kind of pattern in those platforms. And that became available in Java. And so consequently, you're seeing more of that kind of pipes and filters architecture showing up in the Java world just because those native capabilities exist in language. And I think that's been more common in Python for a while because those kind of MapReduce and functional programming concepts have been available in Python for a while. And so it's more common to see those kinds of capabilities show up in architectures just because it's a natural way that developers in that ecosystem think.
And what are some of the architectural anti-patterns that you have found to be the most commonly occurring and the most difficult to address?
It's interesting because most of the architectural patterns that we talk about are structural things like monoliths or microservices, but almost all the anti-patterns are behavioral things that people keep doing stupid things about. So I'll give you a few of them. Most of these get talked about at some point or another in our Building Evolutionary Architectures book. One of them is the witch's brew anti-pattern, where you don't have anyone on a team who's making architectural decisions, and so everybody's trying to contribute to the architecture, and you end up with a witch's brew architecture, which is no clear vision of any kind. It's just sort of a hodgepodge of a bunch of different stuff. Many of the people who are listening to this have come across a project that has 4 or 5 different web frameworks in it, and 6 or 7 different XML parsing libraries in it because there was no real clear vision, and so everybody was just kind of doing their own thing. That's a great example of the witch's brew anti-pattern. Another really common anti-pattern that we call out in the Evolutionary Architectures book is one that I refer to is the meta work is more interesting than work anti-pattern. Because every developer I know would much rather write a new framework than use an existing framework to create something useful, because meta work is more interesting than work. Because, and I ask this question a lot when I speak at conferences, when you really boil it down to its essence. So for most developers, when they're talking to their grandparents or someone who doesn't know a lot about software, and you really boil down their job to its pure essence, they take things from web pages and put them in databases, and they take things from databases and put them on web pages. Yeah, there's a bunch of details in between there, but that's the essence of what they're doing. And once you've done that professionally for 5 or 10 or 15 times, it gets kind of boring. Developers don't like to be bored. And so what developers who are bored do is they invent puzzles to solve at work so that they have cool puzzles to solve at work. And sometimes that's your own homegrown web framework that you have to maintain all the time, when there's a perfectly good open source one that does 90% of what yours does, but that 10%, is somehow critical. And so you spend all your time nurturing this, this baby that you have. But that's a really common anti-pattern that a lot of architecture teams fall into, is we want to chase really interesting things, not things that are actually valuable to trying to get stuff done. And so, a lot of projects end up being these kind of sci-fi research and development skunkworks projects, when that effort could be much better spent, cleaning up old, terrible data and other sorts of pragmatic but not as exciting sort of things.
Yeah, the wonderful not invented here syndrome, and the concept of resume-driven development, where I just want to use this new tool because it's new, not because it necessarily solves the problem that I'm trying to work on.
Absolutely. I did some work one time for a financial services company that had written their own web framework, that had written their own Korma orb, that had written their own application server. I asked them at some point, did you write your own operating system? And they said no. And I said, why not? You've written everything else from scratch. But of course, the problem, anytime you find a company like that, is the very best developers in the company are in full-time maintenance mode of their craptaculous, internally built, half-assed frameworks that, don't do half of what you can download for free from the open source world, because they have platoons of people in the open source world working on those things. And I've seen so many companies are wasting their very best developer talent, who you would hope is right on the front lines of innovation, trying to build the coolest stuff, and instead they're in the worst kind of maintenance mode of fighting rearguard battles for awful homegrown infrastructure.
And you bring up an interesting point there, too, with the rise of open source and its level of popularity and the fact that you can just go out and take advantage of so many man-hours worth of work. I'm wondering if you have any viewpoints on the effects that open source has had on the available architectural styles and the capabilities of software teams to be able to implement successful architectural patterns.
Oh, there's no way that things like microservices could possibly exist without open source. Because here's a thought experiment for you. So let's say it's 8 years ago, and you go to the head of operations of your company, and you go, hey, I got this great idea for this new architectural style. It's really decoupled, and what we're going to do is run every service in their own operating system with their own database. And so I'm going to need 200 Windows licenses and 200 Oracle licenses so I can run each of these services on their own dedicated machines. They would have run you out of your operations center so fast your head would spin. Because it made no sense to do an architecture like microservices if you had to pay per instance the operating system and per instance the database server. That was actually one of the external influences on architecture that we had to deal with for a long time, which was this computing resources are really expensive and scarce, and so you have to build architectures that try to maximize shared resources as much as possible. And so that's where you get things like service-oriented architectures, because one of the outcomes of service-oriented architecture was you could run enterprise-level computing with all these shared resources on, a fixed set of operational machinery. But then an interesting thing happened. And this goes exactly back to what I was talking about before about the shifting ecosystem, was that gradually Linux became good enough for enterprises to start trusting. And of course, Linux is commercially free, but that wasn't quite enough. It was when the DevOps revolution happened and Puppet and Chef and related tools came along, and suddenly Linux became operationally free. And then things like Docker came along, and now you can say from an operational standpoint, look, I'm going to let each team own their own image of the service they're building, and I'll just manage those. And suddenly you have a level of control and responsibility at the service level that was impossible 10 years ago. And so that's a great example of open source enabling some capability that would just literally be impossible in the commercial software world. And we're seeing this accelerate. One of the observations we made on our last ThoughtWorks Technology Radar is that a lot of Chinese companies are starting to aggressively open source software. And there are a lot of software developers in China. And we're starting to see a flood of really high quality open source software coming from China. And they're doing it for the exact same reason that companies like Facebook are open sourcing some of their software. So if you think about it, things like React that Facebook open sources, if this were 10 years ago, that source code would be in the deepest, darkest vault at Facebook with 24-hour armed guards, because that's some of the coolest stuff they have from a company. Why would they possibly open source that? Well, one of the reasons is because if you're in a market like Silicon Valley, where everybody's paying the same amount of money for developer talent, how do you attract top talent? You show them that you're building the coolest stuff. And then people will flock to you because they want to build cool stuff too. That's exactly what's happening in China. The job market is heating up for software developers in China. And so a lot of the big companies like Baidu and Alibaba are starting to really aggressively open source things to show people that, hey, we're building the coolest stuff. You should come work for us. So that's going to have a big impact on the open source ecosystem, because suddenly there's this brand new source of really high quality open source starting to appear that we can start taking advantage of.
And bringing it to the delivery point, no matter how interesting or capable your software system is, it's ultimately useless if there's no way to put it in front of the end user. And I'm wondering, what are some of the challenges that are most often overlooked by engineering teams as they're trying to be able to deliver that software? And what are some of the methods that you have seen to be able to solve for those challenges?
Fortunately, most of those are nicely encapsulated in the book Continuous Delivery, which was written by Jez Humble and Dave Farley and published in 2010. It really, so the name of that book is a really nice marketing move because it's a nice, catchy term. If I had written that book, I would have given it some sort of highly accurate, but never a title it would never sell, like, engineering practices for software projects or something like that, which would never sell a single copy. But that's really what that is. And that really addresses DevOps and a lot of the challenges that a lot of companies have. So, I'm a consultant, so I get to see a lot of interesting broken software in companies. And one of the common refrains that we hear at every company, it's an inside joke within ThoughtWorks, at every single company that we go to, at some point as we're talking to them, someone says, well, but our problem is much harder than everyone else's problem. And it's really not. You just made it interesting and difficult in stupid ways. One of the best pieces of advice that you could do is, so there's this phenomenon known as the out-of-town consultant effect. And what that says is that the further you had to travel to get to a meeting, the more credibility you have. And if you rode in an airplane to get to a meeting and everyone else rode in a car, you automatically have way more credibility than all the car people have. That's the out-of-town consultant effect. But there is some truth to that. Because what happens in companies, so there's a story that's told in the Pragmatic Programmer book. And it turns out it's apocryphal, but it's a great story about boiling frogs. So the Pragmatic Programmer book alleges that if you want to boil a frog, that you can't just throw a frog in a pot of boiling water, that they'll hop right out. But if you put a frog in a pan of cold water and heat it gradually, they'll cook without realizing it. Well, it turns out that frogs are not that stupid, but large corporations are that stupid. And this happens all the time, where the out-of-town consultant comes in and points out that, hey, the thing that you're doing right there is really, really profoundly stupid. And it's almost like the people wake up out of a daze and they go, wow, you're right. That is stupid. Why are we doing that? And it's because, well, we did it this way, and this way led to that way, and so all this history. But the history makes no difference. What you're doing right now is dumb, and it doesn't make any sense from an engineering standpoint. So one of the benefits of this out-of-town consultant thing is looking at those things with fresh eyes. And so one of the pieces of advice I give people is, when you go into work Monday morning, look at everything with fresh eyes and ask, is this really the best way we should be doing this? And I'll give you a great example of this. It's happening on many, many projects right now. Is people are using branches in version control instead of better techniques like trunk-based development. This is a great website run by one of my former colleagues, Paul Hammett, called trunkbaseddevelopment.com. And a lot of projects end up bending themselves into pretzels around the branching strategies they build around their version control systems. This is a great example of meta work is more interesting than work, because they built this cool puzzle around branching and version control and how releases work and all this stuff, where you can use things like feature toggles, and trunk-based development, and branch by abstraction, and a bunch of engineering practices, and actually get better turnaround for continuous integration and other engineering practices, and get away from all the complexity that you're building from branching and other things just because you've done it that way forever.
And going back to your point about fresh eyes being very useful for an organization, is that for companies who are hiring new people, one of the most useful things that you can have them do is, for the first day or week or month that they're on the job, just have them document all of the painful things that they come across in their onboarding process and ask them to fix them or help you fix them, so that the next time somebody comes along, after the new person has already become jaded and submitted to Stockholm Syndrome and think that everything is fine, then the next person can go through the same process, and eventually the onboarding will become less painful, and a lot of their systems will be much improved by the virtue of having those fresh eyes coming in. And that's also where junior engineers can be most valuable as well, is because they don't have all of the institutional knowledge or all of the bad practices that have already been learned, then they can come in completely fresh and say, I don't understand what's happening here. And then if you're forced to explain it, then maybe one of the senior members of the team will also realize maybe this isn't the right way to be going about it.
Absolutely. I think that's a great way. We always encourage people to question anything that we're doing as to, why are you doing that? And, is there a good explanation for why you're doing that? Sometimes there is. And, we're not trying to, get everybody to question every single thing all the time. But, it is good to look at things with fresh eyes and rethink them on a regular basis. I think people get really blind to the habit part of their job, and things change, and capabilities show up that you don't take advantage of, and that's deadly in the software world because everything changes all the time. One of the things that we're seeing out in the world is the gap between companies who really get this and are really investing in engineering practices and can have really fast turnaround on new features. They are pulling away from companies who still have a very 20th century attitude about IT, that IT is overhead and it's a cost center and you try to minimize cost as much as possible. What's going to happen is someone's going to move into their market that is very aggressive in their strategic use of software, and they're going to find themselves in a difficult situation.
And beyond the purely technical aspects of software systems and the technical patterns that go into building them, what are some of the other elements of production software and delivery that are necessary for a successful architecture that we didn't already talk about?
I touched a little bit on some of the soft skills and other things that you have to have as an architect. One of the things that you should really, one of the skills you have as an architect is be a really good presenter and be able to present your ideas really well in front of a group, because that's the only way you're ever going to get to implement any of your architectures, no matter how brilliant you are. And so one of the ways to get your architecture implemented is to convince people that you have the right vision to be able to do this. So one of the things I tell architects, if you've got some new vision for what you're thinking you want the system to look like, you should practice drawing it on a whiteboard so that you can do it without thinking about it. Have you ever seen people who can draw all 50 states, just kind of freehand and draw, the outline of the United States? You want to be able to do that with your architecture, because if you find yourself at an impromptu meeting with someone and they say, hey, Fred's got a good idea for how to solve that problem. Why don't you explain it to us, Fred? The ability to walk up and confidently be able to draw it and not run out of room off the edge and not back up and go, oh, no, wait a minute. Just being able to draw it, that conveys this level of certainty that, you might not have, but it gives you that impression that you've thought through it because you've drawn it a few times. And so all those soft skills about leadership. I've been the architect on projects where there's a fundamental disagreement about things like how we should represent data. And, at the end of the day, both sides of the argument came to me and gave me their best case. And as the architect, I had to decide, and I had to choose one of them over the other. And there was no way they were ever going to reconcile their difference, because it was just a fundamental philosophical difference. And one of the things I had to deal with over time were the repercussions of, picking a winner versus a loser in that particular, head-to-head showdown. So all those little things are the things that, you become an architect by all of your technical acumen, but then the real skills of architecture have little to do with the technical stuff and way more to do with soft skills and presentations and writing and documenting and meetings and setting agendas and scheduling and prioritization and all those other things that are the necessary byproducts of the job of architect.
And one of the things that you mentioned in there that stuck out to me is that a lot of times when somebody thinks about architecture, the concrete artifact that they consider from that is a system level diagram, whether that's the infrastructure that's necessary to run the application or a flow diagram to show the user interaction paths. And those are very valuable things to be able to have for a software system, but due to the nature of change, they very quickly come to be out of date. So I'm wondering if you have any recommendations for tools or practices for being able to generate and maintain those diagrams to be able to help with the onboarding process for for new people so that they can understand the system that they're working with, but also ensure that the diagrams that they're looking at aren't going to mislead them into a false sense of understanding.
Yep, you've hit upon a really, really important aspect of a system, and it actually reinforces something I was saying earlier, that all of these things are living, breathing things. They constantly change over time. So the static diagram you capture right now in 6 months, probably it will have changed in legitimate ways away from that. So one of the pieces of advice I always give people is that as the architect, you want to have some sort of resource for important diagrams for your software project. But I always have 2 directories there. One is current and one is archaeology. And as the architect, everything that's in current is important enough that I'm going to keep it updated to the current state. And as soon as I come to the conclusion that it's more trouble than it's worth to do that, I'm going to move that over to archaeology. Everything in the archaeology directory are things that were important, accurate depictions at one time, but we've moved away from them for one reason or another. So if you're interested in the way that the data design was originally designed to work with the persistent system, then it's there, but that may not be the way it works now. And so as the architect, that kind of holds my feet to the fire for, okay, these things have to be living, breathing documents, and they have to be valuable enough for me to actually put effort into keeping them updated as part of the project. And I think that's the responsibility of an architect, because the worst thing, as you said, to have is some sort of documentation, but then you start looking at it and you go, ooh, created date 3 years ago. Ooh, last modified date 7 months ago. Ooh, I don't know how accurate this is. If last modified date was 3 days ago, and there's only 3 documents in current folder, then you've got a pretty good confidence that what you're looking at is an accurate depiction of what's going on. The other thing that we identify about those kinds of artifacts is that lo-fi is best. There's an anti-pattern that we identify that I call irrational artifact attachment. There seems to be a direct correlation between the amount of time that you spent creating some sort of artifact and how irrationally attached you are to that artifact. So if you draw something on a whiteboard, it takes you 5 minutes and somebody wants to change it, you're not mad about it. But if you spent some tool like Omnigraph or Visio and spent 3 days working on something and somebody starts complaining about it, you'll start defending it because you spent so much time creating it. That's irrational artifact attachment. So lo-fi things are better. And in fact, a lot of times now, I don't do whiteboard diagrams. I draw it on an iPad connected to an overhead projector. So I've got one of the ridiculously expensive little dongles that allow you to attach your iPad to an overhead projector. And I use a drawing piece of software. And that way I can have as many pages as I want. I can annotate them. Those automatically get synced up to my Evernote account, which does optical character recognition on them. And so that's a great way to keep those kind of ephemeral diagrams, is by creating them on the fly using something like an iPad. And then they're easy to update because they're already in electronic format. You're not trying to take pictures of glary whiteboards and other sorts of, MacGyver-like moves.
And for people who are interested in learning more about the principles of software architecture and how they can become more involved and informed in that process, whether as an individual contributor or as a full-time architect, I'm wondering if you have any specific recommendations for resources or sort of practices that they can incorporate into their day to help them progress along that path.
It's actually really, really difficult. A few years ago, Mark Richards, who's a really well-known software architect, and I started looking around, and I made the observation at the time that if you look at, and this is not just in the US, this is pretty much worldwide, the top 10 salary lists, a software architect usually falls somewhere in the top 10 of, most desirable salaried jobs. But how you get to be a software architect is not at all obvious, because there are no good resources to take you from not a software architect to becoming a software architect. And so he and I actually created a series of videos for O'Reilly called Software Architecture Fundamentals that starts talking about all those things. Mark actually does a lot of public training classes around this idea of software architecture fundamentals, because there aren't any really great resources that are comprehensive that tries to touch on all the things, that you have to deal with from a software architecture standpoint. So there are a lot of resources you can find out in the world around software architecture patterns. There are a lot of pattern books out there. Martin Fowler has a Patterns of Application Architecture book. There's a book by Gregor Hope and Bobby Wolf on enterprise integration patterns. So these are all the integration architecture patterns that exist out in the world. But one of the problems you run into there is that you read about patterns until you're blue in the face, but until you actually get to implement some of these things, it's hard to get the kind of practical application. And that's a real fundamental problem with architects is you don't get to create new architectures very often. You get to work in existing ones a lot, but creating new ones is quite rare. And so one of the exercises that we go through when we do a software architecture fundamentals class, and I'll turn this on for all your listeners here if they want to do this. On my website, there's no obvious link on my website, but if you go to my website, which is nealford.com, it's my name, nealford.com/katas, Katas. That leads you to these architectural katas exercises. Each one of these is a little puzzle that's a list of business requirements and a little bit of additional context. And when we do a training class, what we do is create little teams of 3 to 5 people as architects and then assign each one of them one of these katas and have them go through all these architectural processes of identifying what architectural characteristics are important, what are the component boundaries, what sort of architectural pattern would be suitable, etc. And so people who are listening to this can go through this exercise themselves if they want. So get some people within your company who are interested in software architecture together for like a brown bag lunch, go through a katas exercise and then get some existing architects in your company to come make some comments about your design. What did you get right? What are the things that you missed? And work through this process because the only way you get better at anything is practice it. And so this is a way that you can actually practice the practical mechanical parts of software architecture of assessing trade-offs and identifying component boundaries and that sort of stuff in a sort of a classroom style setting.
All right. And are there any other topics that we didn't cover yet that you think we should discuss before we start to close out the show?
No, I don't think so. We touched on, I think, one of everything.
All right. There are definitely many areas that we could have gone much deeper on, but those are probably an entire episode unto themselves. So hopefully this will serve as a useful overview to people who are interested in learning more about the ideas of software architecture and how they can begin applying that in their own roles.
Yeah, it's definitely a big topic. Just evolutionary architecture by itself, of course, is a big enough topic to write a book about. So, there's a lot of stuff going on in that world, and it's ever changing. So it keeps me on my toes.
And for anybody who wants to follow the work that you're up to or get in touch, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us on into the picks. And this week, I'm actually going to choose a couple of different movies that I watched yesterday that both happened to be about the jungle. I didn't do that consciously, but I went and saw the newest Jumanji movie in the theaters yesterday, which was absolutely hilarious. So I definitely recommend everybody go and watch that. I had a good time with my whole family on that one. And then yesterday evening, I watched The Lost City of Zed on Amazon, and that was based on a true story of a British Army officer who spent a lot of time exploring the jungles of South America in search for lost civilizations. So that was an interesting story and well presented. So for anybody who's curious about that, I definitely recommend that as well. And so with that, I'll pass it to you, Neal. Do you have any picks this week?
Yeah, I'll give you one that just came out. You were asking me earlier about good resources for burgeoning architects. There's a great website that Mark Richards just created called developer2architect.com. It's just the word developer, TOarchitect.com. And it's a great resource that has videos and white papers and a bunch of other stuff for brand new architects. So that's a good resource for people to check out. And Mark only just launched this a few weeks ago. We have a website around our book, and we're actually starting a blog series shortly illustrating a bunch of the things in the book. It's at evolutionaryarchitecture.com, and there's some other resources there related to the book. Something completely unrelated to software architecture that is this science fiction book series that has really captivated me and a bunch of my friends. It's the Broken Earth series, and the first one of them is the 5th season. Really terrific book. The third one just came out. I think they've all won awards, and for really good reason. Really, really inventive world building, really fantastic science fiction book series. I'm just finished up the second one, and I'm chomping at the bits to start the third one. So if you like science fiction world building, and this is set so far into the future that the continents have merged back together into a single continent, so very far future kind of science fiction. It's a great piece of work.
Yeah, that definitely sounds very interesting. I'm currently reading a sci-fi series myself that I mentioned in one of the episodes I recorded recently called the Berserker series by Fred Saberhagen, so I'll have to take a look at the Broken Earth series.
It's so good, but boy, it's deadly. Once you start reading it, you can't put it down, so reserve some time.
All right. Well, I really appreciate you taking the time out of your day to join me and talk about the work that you've been doing in the software architecture space. It's definitely something that I have found interesting for a while and hope to continue to learn more about. So thank you for your time, and I hope you enjoy the rest of your day.
Yeah, it's my pleasure. Thanks for having me.